Today we're going to start looking at the basics of optimization in calculus. The underlying concept of optimization is actually quite simple. We're either trying to maximize or minimize a value, knowing that there is a constraint, and basically all that is application of derivatives. We're using critical points to find the maximum or minimum. The hardest part is knowing what the problem is asking for and how to set up the problem. So today let's look at some basic examples to know how to deal with optimization problems. So let's look at this problem. This problem says find two positive numbers that add up to 300 and whose product is maximum. So we're trying to find two positive numbers that are going to add up to 300 and whose product is going to be maximum. I encourage you to take note of this, know what the problem is asking for, know what we already know, and let's go from there. We'll represent the two unknown numbers by x and y. So x plus y is equal to 300. Now that's the constraint. And we're looking for the maximum product yielded by x and y. So p equals x times y. The problem we have here is that we have two variables, x and y. We would rather deal with one variable, and in order to do that, in the constraint problem, we can isolate one of the variables. I like to isolate the y. So let's say we're going to isolate y in this case. Y is equal to 300 minus x. All I did was subtract the x from both sides to isolate the y. Now we can just plug in this as y in the equation, p equals xy. So p equals x times 300 minus x. Again, all I did was replace the y with 300 minus x. Now, we want to distribute this x. So p equals 300 x minus x squared. To find the maximum or minimum, we have to find the derivative. And in this case, we're looking for the maximum. So we're going to take the derivative of p, which is p prime. That equals the derivative of 300 is just 300. The derivative of 300x is just 300 minus the derivative of x squared is 2x. And to find the critical points, which is necessary to find the maximum and minimum, we're going to set p prime equal to 0. So 0 equals 300 minus 2x. Isolate the x, so add 2x to both sides. 2x equals 300. To figure out what x is, we just need to divide both sides by 2, and we get x equals 150. Now this is a critical value, and it's the only critical value, so it might be the maximum, but we want to make sure. So what we do is draw something like a number line with 150 over here, and we know the numbers are positive, so it has to be greater than 0. To find out if the slope or f prime is positive on the interval 0 to 150, we have to take a number that's in the interval. So let's take 1 and plug that into p prime. 300 minus 2 times 1, that's a positive number. And let's take something that's greater than 150. Let's say 200. So 300 minus 2 times 200, that's a negative number. And we know a positive slope followed by a negative slope yields a maximum point. So at x equals 150, there's definitely a maximum point. But we're not done yet. We're looking for two numbers. We know x, now we have to figure out what y is. In order to figure out what y is equal to, all you have to do is look at this equation right here. Y equals 300 minus x. We already know what x is, so we can just plug in to get the y value. Y equals 300 minus 150. And we get y is equal to 150. So now we know both of the values that we were looking for. Now let's look at another problem. Something that's a little bit more complex but not too bad. So again, I encourage you to write down the problem and know what the problem is asking for and what we already know. So a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? This might seem like a lot, but all we need to know is that the farmer has 2,400 feet of fencing. He needs no fence along the straight river, and we're trying to optimize the area and find the maximum area. So let's start doing that problem. For problems like these, I always like to start by drawing a little diagram that represents what's going on. So this is the straight river, and this is the fenced area. Let's just say these sides are x and this one is y. Keep in mind that there is no fence along the river. There is no fence right here. So the 2,400 fence is going to be a sum of x plus y plus x. Therefore, 2,400 equals 2x plus y. We're looking for the largest area. So A is equal to x times y. Now, just like the last problem, we have two variables, but we would want it in terms of one. What we can do is go back to the constraint problem and isolate the y, and then we would have everything in terms of x. So y is equal to 2,400 minus 2x. Let's just go ahead and plug in y is 2,400 minus 2x into the area equation. A equals x times 2,400 minus 2x. Now we can just go ahead and distribute the x. So A equals 2,400 x minus 2x squared. To find the maximum, we need to find A prime. A prime is equal to the derivative of 2,400 is just 2,400 minus the derivative of 2x squared is 4x. To find critical values, we have to set A prime equal to 0. So 0 equals 2,400 minus 4x. Now we can isolate the x, add 4x to both sides, for x equals 2400. Then just divide by the 4, x equals 600. Now that's the only critical value that came from the a prime, but we want to make sure that that is a point of maximum, a relative maximum. So we're going to draw something like a number line with 600 over here, and we know that x cannot be 0, it has to be more than 0. If it was 0, then there would be no area, and since it's a length measurement, it's also not negative, so x definitely is greater than 0. To figure out if a prime is positive or negative in the interval 0 to 600, we have to take a number that falls in the interval and plug it into a prime. For the sake of easiness, for convenience, let's just use 1. 2400 minus 4 times 1 is a positive number. So a prime is positive on the interval 0 to 600. To figure out if a prime is positive or negative for numbers that are greater than 600, let's plug in, let's say 1000. So 2400 minus 4000 yields a negative number. And we know a positive slope followed by a negative slope gives us a point of maximum. So that x equals 600 is definitely a point of maximum. But we're looking for dimensions. That means we also have to know what y is equal to. To find y, all we have to do is refer back to our constraint equation, y equals 2400 minus 2x. We know what x is already, so we can just plug in and find the answer. 2400 minus 2 times 600. Y equals 1200. Now the fence was in terms of feet, 2400 feet, so the dimensions are also in terms of feet. Don't forget the units for equations, problems that require the units. So our final answer is y equals 1200 feet and x equals 600 feet. So that sums up my video on the basics of optimization. If you haven't already, subscribe to our channel, as I'll be uploading more videos related to calculus, AP Physics, accounting, and Excel tutorials. What I like to do is always upload a part that shows the basics and then go into more depth in the following videos. So this will be followed up by a more in-depth video. If you haven't already, like the video, share with anyone that might find it beneficial. Until next time, take care, guys.